I process an equation with a condition which is a constraint. Y equals 2 times x is the constraint. I solve the constraint equation for one of the variables. The required value of x equals y times x is the equation I optimize. I integrate this constraint equation into the formula that I optimize. The value of x equals 2 times x squared is the formula after the substitution. If I determine the optimal value of a function and consider its constraints, I consider the extreme values of the function with two variables. I connect both variables with an equation. I integrate this constraint equation into the formula that I optimize. I determine the maximum or minimum value of the objective function by creating the first and second derivative of the objective function. Local extreme values possess their minimum or maximum values in the environment of X. I find the minimum or maximum values of global extreme values in the entire interval. Local extreme values can also be global extreme values. I integrate this equation with a condition into Bayes' formula. I use this technique to process multi-objective reinforcement learning tasks, including an inverse reinforcement learning technique. I integrate this procedure in a reinforcement learning model for one or multiple agents. The LSTM network solves the partially observable Markov decision process. I define a mathematical equation which connects the domain task with the reinforcement learning technique. The following factors influence the result of the agent's interaction. P designates the probability of finding a suitable variable, item or word, and to receive a reward. Upsilon designates the utility of the agent's last action. Omega is the utility of the action proposed by the second agent. C is the degree of suitability of m-1 operators and n variables. And S designates the structural deadline. These factors influence the result of the agent's interaction. I calculate the next spread of the interaction values. My first state of the Markov decision process is the interaction function. The function is the state. I search for an action for this first state by using Bayes' formula.